Hello students, welcome back to my class. Today we'll be learning about the laws of thermodynamics. Are you confused or stressed listening the words like laws? Is very simple, okay? We can see that in the practical applications also in the real life scenario. Okay, let me explain. Zeroth law of thermodynamics. It's a COVID-19 situation, right? Pandemic situation. The most common symptoms in the COVID is fever. Okay, now if a doctor comes and tries to measure the temperature of a patient, so he will use a thermometer to measure the temperature. So when the thermometer is in contact with the body, the temperature rises, right? The value of temperature increases. It's a magic. The temperature of the thermometer is trying to be in equilibrium with the body. Simple. So zeroth law applies here. So what if a third body is coming and trying to be in contact with the already thermally equilibrium two bodies? The third body will also become in thermally equilibrium state. Yeah. So this is the zeroth law. Now let's move on to the first law of thermodynamics. I guess most of you have studied that in your lower classes. It's very simple. Which states energy can converted from one form to other form. It can neither be created nor be destroyed. Did you recall something? Okay, let me give you a real life example. There's water in a tank. So it is stagnant, it is not moving. It's having some kind of potential energy. Now if you open the tap, the water starts flowing. So you are converting the potential energy into kinetic energy. And with the moving water, if you keep a turbine, now the water starts rotating the turbine, and this turbine can be converted the kinetic energy of the water into electrical energy. So there's a whole magic of conversion, right? It's very interesting. Energy conversion from one form to other form. Okay. But there's a limitation for the first law. It states that you can do the energy conversion, but you cannot find the direction of the conversion, like which direction the conversion is happening. Let me give an example. There is a coffee, you are placing it in like a room temperature, in a mug. So now, gradually the temperature of the coffee will reduce, but can you try to make the coffee hot again just by simply placing it room temperature? No, right? You need an external source. So this means that this process is not spontaneous. So here the second law of thermodynamics comes into picture. Before that, there's one more term, okay? It's called entropy, which measures the amount of disorderness. Okay. Disorderness is always related to heat. So the second law of thermodynamics states that the value of entropy is increasing with time, and the entropy can never be negative in an isolated system. Okay, that's completely relatable to my previous example, that you cannot make the lukewarm coffee into a hot coffee again without any external source, right? So entropy is always related to some kind of disorderness. But can entropy be constant? Because we have already just now seen that entropy is keeping on changing with time. Or entropy cannot be negative. Entropy can be constant at an absolute zero temperature. Okay, so that's the third law. It states that the entropy of a system at absolute zero temperature is constant. I guess you are clear with all the laws. Thank you so much.